welcome to this new class. Today we are going to discuss about galvanic corrosion and differential aeration corrosion. So today, what the type of corrosion? So what is the corrosion? So what are the types of corrosion? So we are going to discuss one by one. Yes, what is the corrosion? So slowed continuous destruction of metal by the environment is known as corrosion. So the more active metal acts as anode. So corrosion always takes place at anode. So best examples are rusting of iron is the best example, and formation of a green layer on copper surface. So both are the very good example for corrosion. Then next one is galvanic corrosion. So there are two types of corrosions we are going to discuss in this class. The first one is galvanic corrosion. What is galvanic corrosion? So galvanic corrosion means when two different metals are in contact with each other, then a more active metal acts as anode, less active metal acts as cathode. So more active metal acts as anode means, so for example, copper, zinc. So compared to zinc and copper, zinc is more active metal. So why it is the standard reduction potential value is minus 0.76 volts. But in the case of copper, so the value of standard reduction potential value is plus 0.44 volts. So more less value is known as more active metal. So compared to these two, zinc is active act as an anode, so copper act as cathode. So this is galvanic corrosion. So let us consider. So we are going to discuss one by one. So take a zinc. So new zinc. So color is good. The shape is good. So but in the case of later 8 months, so after 8 months, so the zinc is corroded. Why it happened? So the reason is the galvanic corrosion. Two metals. So see. So this is a different metal. So this is a zinc. So the two different metals are in contact with each other. The corrosion takes place at the zinc. So the shape of the new zinc is entirely different from. So after 8 months, so the shape of this material is corroded. So the reason is galvanic corrosion. In industries, so many examples are there. So for example, this bolt nut. So both are in same metal, there is no problem. But in the case of different metals, more active metal acts as anode, so corrosion takes place. So see in this, so many industries, so many buildings, so they are having these type of corrosions. So this is known as galvanic corrosion. The second corrosion. So what we are going to explain is differential aeration corrosion. So this corrosion is nothing but when two metals, so let a metal is partially immersed in one solution, then the top part of the metal is less aerated or more aerated. So based on this, so corrosion takes place. So yes, next one is the diagram. See the diagram. So this area is more aerated area. So this acts as cathode. This is less aerated area. So this acts as anode. So corrosion takes place here. So this type of corrosion is differential aeration corrosion. So we can see so many examples. So pitting corrosion, then soil corrosion, so water line corrosion. So we will discuss one by one. So yes, next one is so water line corrosion. In the tank or the dam, so it's a bridge, so which is made up of metal, is made up of this metal. Then this area acts as less aerated area, so corrosion takes place here. So this is also one type of differential aeration corrosion. The next one is pipeline corrosion. So what is meant by that? Buried pipeline. So passing through different soils. So number one is this clay. The soil contains clay. So this is here the soil is sand. So clay and sand. So both. So the pipe is passed through these two areas. Clay area is less aerated. So this is sand is compared to these two. Sand is more aerated. So less aerated area acts as anode. So this area acts as anode. This area acts as cathode. So corrosion takes place here. The corrosion affects, disturbs the metal here. So this type of corrosion is known as differential aeration corrosion. This is a pipeline corrosion. Next one. The next one is pitting corrosion. Take any metal. So metal is on the surface of the metal. So some droplets, some the dust particles are present, then that area acts as anode. Why? The reason is this is lacerated area compared to other area. So that area acts as anode, so corrosion takes place. So this is also pitting corrosion. Why pitting corrosion? Why pit? How pit is formed? So in this area the corrosion takes place, then the corrosion products are can be removed, then corrosion takes place here. Why? This is the lacerated area, corrosion takes place, then again and again, so corrosion takes place. At one stage a pit, a small hole is formed, that is called pitting corrosion. It is also under the differential corrosion method. Yes, next one is this is another method, corrosion on wire fins. So we know the fencing in so many areas. So we can see. So it's a fencing. And the fencing. So this area is so dense part. This is a loose part. So comparing this area and this area is less aerated or more aerated. So this is less aerated area. This is more aerated area. This less aerated area acts as anode. So corrosion takes place here, right? So this is corrosion on wire fins. So this is also one type of differential aeration corrosion. The next one is okay. So many types of corrosions are there. So today in our class, so we discussed one is differential aeration corrosion, and the second one is the galvanic corrosion. Thank you very much.